Okay, welcome to the second part of the series of automated gardening with the Arduino Uno R3. So this video is just going to be going over exactly what you need to actually create the process. Just anything that you might need, what I'm recommending, what I used, so on. Okay, so first things first is we need a microcontroller. So Arduino is open source. So if you see something that says Uno R3 and then like Elegoo in front of it, I might be pronouncing that wrong. That is the exact same thing as the Arduino version. They just printed themselves. It's open source software or hardware, even both. So they can go ahead and print it, and it is the exact same thing. So if you would like to, you can buy the Arduino or just buy the Elegoo. I personally bought the Elegoo one. And then most of my other projects are with Raspberry Pi stuff. So big fan of the Pico and the Pico W board. Also have a Raspberry Pi 2 and some other things. So as far as what you want to buy, if you're just doing this project and you already have a bunch of the stuff, I would say go ahead and get that top option, the Elegoo Uno R3. It's $16.99. There might be cheaper options, um, but I would just say that one's fine. However, if this is your first project and you're debating really kind of getting into um, utilizing microcontrollers and stuff like that more, I would definitely go ahead and get the Project Super Starter Kit or another starter kit like it. It has everything you might need from LEDs, resistors. They have different types of um, motors and things like that in there, LCD screens, stuff that I'll get into further in this project as make it more and more advanced. So I would highly recommend getting a starter kit if you're gonna pursue other things or you think you might pursue other things. It's really cool to see all the different attachments and other items in there. Second thing is you're going to need some PCB boards or breadboard. Okay, so if you want to make a bunch of connections in one spot, the Uno R3 isn't really good for that because there's only one little hole per thing and you'd have to go and make the connection elsewhere. And the easiest place to do that and make it so that you can undo connections and redo connections is with a PCB board. You can just solder right into it and then connect as many holes as you want, and it's undoable, if that's a word, and you can just go ahead and solder anything you'd like. If you want it to be more temporary or you're going to have a lot of space in between your connections, you can go ahead and buy a breadboard and just stick your solid wire into that. And that is going to be just fine as well. It just might fall out. So if it's going to go through any movement, you're really going to want to solder it. And that would, again, suggest the PCB boards. You can also make your own PCB boards, like with the copper, where you just kind of draw your circuit on it and then dip it in acid, and then it'll stay of wherever you drew it. I'm probably not going to do a video like that, but there are options like that. There's also websites where you can make your own PCB boards. So there's lots of options for these. I personally own this, just a bunch of PCB boards. You'll see that when I go ahead and show you actually how to build it in person. The next part, which we didn't fully talk about yet, is power supplies. So the Arduino can only output a very small amount of power. If you're going to power this thing through the USB only puts out half of an amp. So if you're going to power something like a motor, it's usually going to draw more than half an amp, and you're going to blow up either the USB port or something on your Arduino. So you really need to be cautious of the amperage. So part of the relays that I was showing you before, um, you really want to have your own power supply in that. So I would recommend getting something like this, a DC 5 volt 2 amp power supply. Now, it doesn't matter what the connector looks like because I'm just going to cut it off. We're essentially buying this. It's going to go and plug it into the wall so that the motors always have a charge. If not, you could always also get a battery. There's lots of 5 volt, 2 amp batteries, 2000 milliamp batteries you can buy. Uh, Again, we're just going to chop that off, take the neutral, the ground and the positive, and we're going to um, just connect those in the circuit. The positive would be cut off via the relay. So I'll show you that in a later video, but that's essentially how it's going to go. Next thing we need to talk about is a wire. So if we're going to connect the wires all together, you need to do a wire calculation of exactly how big your wire needs to be. I didn't check this website to see if it's actually good. When I was an electrician apprentice, I had a little book that would tell me exactly what size wire I needed to use over what distances and over for what voltages. But that was in commercial, and we weren't doing really any low voltage work. So the source voltage for this project is 5 volts. The 3% allowable voltage drop was just in there already. I didn't change it. It's fine. Conductor material is going to be copper. Do not use aluminum. Current is going to be 1 amp, probably max. And then I put one-way distance is 20 feet. Realistically, for the video that I'm going to shoot for you, it's going to be like 10 feet max. So I'll go ahead and put that in. You can see it changes the wire gauge. So how this works is the higher number the wire gauge, up to a certain point at least, the smaller in diameter the wire gets. So 17 is a very small wire. And if I went back to 20 feet, you'd see it gets bigger to 14. Most of the wiring in your house is 12. And you can plug it in and see exactly what wire you should get. If anything, it's better to oversize the wire than undersize the wire, because if the wire is too small, it heats up and won't take the amperage that you want. So you can go ahead and buy wire on Amazon. So I just clicked on one of the first links that I actually saw. 100 feet, 14 gauge wire. This is 14-2, meaning that there's 2 strands. So there's a red and a black, which I personally like if we're going to do DC current. It's mostly red and black. And it's stranded. So you can see how there's a lot of different strands of copper in there. I personally like using stranded better than solid. Solid would just be one harder solid piece of copper that makes it harder to bend. And it's kind of easier to solder in some circumstances. But overall, I just like working with the stranded more. It's easier to connect to itself as well. So I would highly suggest getting stranded wire. So that's 1,400 feet, $18. It's not really that bad. There are other options if you wanted to look at other aspects. And then there's also these heat shrink wire connectors, where if you wanted to get some of those to connect to other parts of the wire, you could do that as well. Okay, next is a soldering kit. You heard me talk about soldering before when we were going over the PCB boards. The soldering kit is kind of make or break for a lot of projects. So you can see this one here on the top left has holders, and those are very, very useful, especially if you don't have someone to sit there and hold your parts. You can just clamp it in, solder it, and then there's a little place for the actual solder iron to go so you don't melt through your desk. Has some solder with it, and you can change the temperature of the solder iron. Now, comparatively to this $10 one, yes, you get the solder. Yes, you can change the temperature with this little dial. You get these other parts here. This would work fine. This little flimsy solder holder doesn't work very well. The soldering iron falls off of it, and it's not heavy, so it won't like stay there. But it'll work. So if you're on a budget and you just want a $10 solder, you're just kind of getting into it, you're not sure if you want to continue with this kind of thing, I would say just get the $10 one. If you're going to stick with it and you really want a good kit, I would say maybe get the $50 kit. The other thing that you might want to get is flux, which we'll go over when I do a soldering video, or you can just look at another soldering video. They always recommend flux or flux in the wire. So look into that. That's kind of a big choice, so definitely do your research on solders. Personally, I have a $20 soldering iron, and it works just fine. So you can't really go wrong with one. You can just go to Home Depot and buy one. It doesn't really matter. Okay, the next thing that we need is a moisture sensor. So personally, what I have is the moisture sensor right here. It goes in, it's fine. There's no issues with it so far. The only thing that I have noticed is that leaving it inserted into the ground, having this large board surface, there is a lot of condensation buildup. Now, I live in an extremely humid area. Um, Actually, sorry, I have these over here. Not this brand. I have this brand, and it's the 5 sensors. Um, so the humidity does kind of condensate on top of the large board. So would something like this work better or something like this work better? I don't know. It might. But these do work just fine. I haven't had any issues with them. When the soil's dry, the um, condensation pretty much just goes away. So you could pick any of them. It doesn't really make a difference. If you're going to pick this one, you're either going to have to cut these wires if you didn't buy the starter kit, or if you did buy the starter kit, it does have some connector pins in it that you can just go ahead and use to connect to uh, these connections here. Okay, next is the pumps. So I bought these pumps here. They're 3 to 5 volt micro submersible pumps. They worked fine. There was a few reviews on them saying that, hey, they stopped working after a day. Personally, I've not seen that. So no issue for me whatsoever. So you can see also there's like amperage rating and things like that. And I haven't run into any issues. You can power it directly off the board if you wanted to, but you can only do one at a time. It's they do take 0.18 amps of current, which is not a whole lot. But if you really wanted to, you could just use a power cord like this and then reduce the amperage. Okay, so that's the pumps. If you're going to do something like stronger, I would suggest a pump like this. So if you're going to want to pump up and do a hydroponic setup instead of what we're doing now, you're going to want something that can go up like 8 feet high, pump up the water and mixture of whatever you're putting in there. Something like this would be much better. And you could still use this with the relays that we're buying, which brings me into our next tab. Okay, so for our last thing that we need, and I might have forgotten something, and if I did, I'll put that in the description, is a relay. Now, all relays are not created equal. This one has 4 on it, and you can see it goes up to 10 amps of 250 volts alternating current, so the current that's in your walls, or it goes up to 10 amps of 30 volts DC. Okay, so that is like batteries in the US, things like that. So those are the rated. So you can see it down here too. 250 AC, 10 amps, and DC's 330 with 10 amps as well. Now, your typical electrical circuit in the wall, you're not going to want to go over 15 amps of AC. Otherwise, you're going to risk blowing out your breaker. So you can use 1, 2, 3, or 4 of these. It really just depends on the pins. So you can see, can I click this? Yes. So you can see there's the ground, there's the voltage where you supply the 5 volts, and then you have your in 1, in 2, in 3, in 4. And then you have your relay 1, 2, 3, and 4. So if you provide that current that we did in the first video to the 1, it's going to go ahead and close the normally open, and so on and so forth for the other ones. So this is where we would put in our cord, our power cord here. So you would essentially put in the positive end and then run a new cable out to the pump, and then the neutral would then go off of that, or sorry, the ground. So you could also buy, if you were just going to do one pump, or two, you could buy the 2-channel one. If you're going to buy one, they have singular ones as well, where you could do the same thing. It's really up to you. Personally, I have the 4. I'm planning on buying more beds to actually water and stuff, so this is what I would recommend. So the last thing, and this depends on the pump that you buy, is you could see there's pipes here. You're going to need some sort of hose to actually take your water from the pump to wherever you need it to go. So you could plug the end, drill holes in it if you want to water the whole bed, or if you just want it to come out just at the very end of it, you could just stick it there, zip tie it to wherever you want it, and be done with it. You see this pack kind of has the whole 9 yards with it. But that depends on your pump. So if you get this pump, it'll tell you exactly what tube size to use. 6 millimeter inner diameter by 8 millimeter outer diameter. So that's the hose that you need to buy to connect to that little nipple part there. So that's the last thing you need to buy. I didn't want to put one up because it depends on your actual pump. So make sure you get the correct inner diameter and outer diameter tube or hose. Other than that, that's pretty much all you would need. If you wanted to get LEDs or resistors on your own, then you'd have to also buy those. I will put in a build with all of the parts here that I've listed in the description with pricing on it as well. So you can go ahead and look at that. If you have any questions, go ahead and ask them in the comments. I'll be sure to answer as quickly as possible. Don't forget to like, share, and subscribe. See you in the next video.